you and your families are fine and in good health. Well, as you can see on the slide, today we are going to talk about propositional logic. But before we do that, let me just go over the things we discussed in our previous videos. As you remember, we talked about categorical logic in our previous chapter, and we said that the basic unit in categorical logic is categories, because we are talking about categories or classes, and we call those categories terms. We said that there are four major claims. The first one was an A claim, which is also known as universal affirmative, because we say all S are P. And then the universal negative, E, the particular affirmative, I, and the particular negative, O. We also talked about Venn diagram and square of opposition, as well as a process of aversion, process of conversion, and finally the process of transposition. Lastly, we said how we can use the Venn diagram to check validity and the rules method to check validity through distribution. Now, in this video, we are moving ahead to talk about a more modern kind of logic, which we call functional truth logic or deduction. This is also known as propositional logic. It's called propositional logic because the unit we use here is no more categories. Remember, the previous one was called categorical logic because the units we used were categories. But here, the unit we use is propositions, so we call them propositional logic. But the thing is, sometimes we might worry what a proposition is. Is it the same as a statement or whatever? There might be some differences. Remember, when we are using a statement, let's say, we are actually talking about the language which is used. We are talking about wording, right? But then when we are talking about the proposition, we are talking about meaning. So in a minute, you will see different propositions. But if I say I'm from Iran, this is a statement, obviously, and it has some meaning. So that's a proposition, right? If I say I come from Iran, obviously it has the same meaning, but you can see that I'm using a different language. So it means that I'm having two different statements, but same proposition. So again, when we use propositions, actually we are focusing on the meaning, but when we say statement, we are focusing on the wording. Now, remember, in categorical logic, we had two terms for each proposition or each claim. We had two terms. But here, for the whole proposition, we'll be using one and only one letter, which will represent the whole proposition. So, of course, we're going to see this later in our files, but in modern logic, the whole thing is the proposition, which can be denoted as whatever letter you choose to use. Again, because we are dealing with propositions and not classes. So today we'll try to familiarize ourselves with some concepts in propositional logic. Some people wonder why we symbolize arguments. The reason is very simple. We do that to simplify things, to make them quicker, and to be able to check the validity of the arguments maybe more quickly. Besides, it's fun, and I guess first let's see how we can symbolize some propositions. Look at the sentence, I'm from Iran. This is a proposition, right? We can use a letter to symbolize it. Let me use I. So this is a symbol for my first sentence. How about this sentence? I'm a teacher. Okay, so this is the symbol for my second sentence, right? I've used T to symbolize it, maybe because of teacher. Now look at this third sentence. How can I symbolize this because there are two propositions, and there is an operator and, as you can see here. So there's and as an operator, and there are two propositions. Because for I am from Iran, I use I, and I'm a teacher, I use T. So let's just write I. Here we have and here we have T, I and T, right? Okay, and this last sentence, how can I symbolize this? You will see later, then not is a negator, we say, or the operator is negation. So I'm from Iran is I, and not is added. So what I can write is I, and then bring this not down and write not I, just like what you see here, not I. Okay, so this is the symbol we would be using for a negative sentence, or sorry, negative proposition. Let me just put it. Okay. Now let's look at the truth value of each sentence. When you hear a proposition like, I'm from Iran, this is a proposition. And let's say that this is an I, like we had it before, I. And any proposition we put forward might be either true or false. Is that right? Then I can write, if I is true, then what does it mean? That it means, or it is true that I'm from Iran. But if it is false, then it is false that I'm from Iran. Well, if we have one proposition, we'll have then two possibilities. One is false, one is true. Then what is the opposite of I'm from Iran? That would be I'm not from Iran. Is that right? So we will have two possibilities for a sentence or a proposition like I'm not from Iran, and that is again true or false, right? So these would be the sentences. If not I is true, it means we have a negative proposition. If not I is true, then it is true that it's not the case that I'm from Iran. And what is the opposite? I mean, if the not I is false, then it is false that it's not the case that I'm from Iran. So you see there's double negative in a sense. Now, if you just, excuse me, if you have this table, then the truth value would be able to help you understand things better. Now, remember the sentence, I'm from Iran, this is P, for instance, okay? So that's a proposition, which might be either true or false. But what is this tilde? Tilde is a symbol we use for negation, that's right. Okay, so now if this is true, then the opposite sentence would be false, right? And if P is false, then obviously not P would be true. Is that right? Okay. Let's look at some compound sentences. Well, the first one is what we did. I'm from Iran. I'm a teacher. We say it's a compound because we have two events here. One, I am from Iran. And two, I'm a teacher. And we have the operator and. Okay? Good. Now I'll show you some other sentences. I want you to symbolize them by letters only. Okay? Okay, now you can pause the video and symbolize these sentences. Okay, now here we have the response, the key actually to the compound sentence we have. You see, the first one was John is a good man, and we used the letter G for that. The second one, John is a good and kind man. Maybe some of you did not write two letters for them, just wrote one. But actually, there are two because we have an operator, and that is and. Okay? So this is important for us. So in a sense, we can say John is a good man and John is a kind man, okay? So that would be G and K then. Next, John is either a teacher or a student. So we can just say John is a teacher or John is a student. So John is a teacher is T, or is our operator, and S is John is a student, okay? Now, the next sentence is a negative sentence, right? So we have John doesn't like this lesson. So let's just use lesson L. And because it is negative, so we just write not L, okay? So this is how we write it. Next we have if and then, okay? We use if then, that's another operator, okay? And then here we have a proposition. John studies hard. Here we have another proposition. So this is how we can write if S, then P. Okay, so if John studies hard, then he will pass the course. And finally, there is one where we have, in a sense, three operators, or we can just call it one operator. Okay, if we consider it as one, we call it if and only if, which is called a biconditional or an equivalence. Then we have one proposition here. John will pass the course, and one here, obviously, he studies hard. So let's say just this is P, pass, and he studies hard, S. So P, if and only if S, right? Okay. Now here in our book, this is written. I mean, this is, sorry. This is an easier version of writing it, but in our book, it has written it using a different method, and that is use if and only if and write it this way. I'll try and explain this later to you. So as you can see here, one operator is if, another operator is if, and one operator is and, right? But something maybe worth mentioning is if you have more than two propositions, that means that we need operators. If there is only one proposition, the only operator that can work is actually negation. It means here, for example, we have one. Sorry, I have to clear my throat all the time. Sorry. You have one only proposition, but because it's negative, so we have the operator. But with the rest of them, I mean, with and, or, if and only if, we need at least the two propositions. Now a question. If we have three propositions, how many operators should we at least have? Three propositions, at least two. Why do I say at least two? Because we might have more operators. And what operator will that be? That would be not. Maybe all the propositions I have are negative, right? So what matters here and what is important to remember is that if there are more than two operators, or if there are two operators or more, better say if there are two operators or more operators, then one of them plays the part of the major operator. It means you will have to decide what the major operator is, okay? We'll discuss this maybe in our next videos. But for now, just look at this. We have one if, right? And later we'll see how we will symbolize this. Here, so we have if as an operator. It applies to S and it applies to P. Okay, so S to and P. Here, the same thing, if to P and S. Okay, but this one operates on both this and this. I mean, the whole thing. Okay. Okay. Let's look at the symbols I told you about. So have a look at this table. You can pause the video and have a look, okay? Then you will see what these operators are, what the symbols are, and whatever. I have used the two symbols for conjunction and condition. This is because in many books that you read, you might just find these operators, okay? And for this last one, I've used a triple bar that you do not have in your books, but this is also maybe something worth mentioning. I'll tell you how we do it in our book, though, okay? So the first one, the operator tilde, this wiggly line or wiggly dash, is negation, what we use for negation. And the words that we use for that are not, or it's not the case that. The operator and takes the form of the ampersand, right? Or a dot. In our book, we use an ampersand, and it's used for conjunction. There are words like and, also, but, which are represented by an ampersand. A wedge is used for disjunction. That's when we use or we use unless, and we'll see how, although unless can be considered as an if, we use it with a wedge. Then arrow represents condition or implication. You can just say if X, then Y, or only if, and then we'll see how these two things might be different. And finally, we have a triple bar, which is used for equivalence, or sometimes we call it by conditions or by conditionals. And then it is used when we have if and only if, and then we'll see how we might use a different way to symbolize it rather than the triple bar. Okay, now, so we have some compound statements. Well, of course, not all of them are compound, but anyways, we have some propositions. Please pause the video and rewrite these sentences using the operators we learned plus the letters. You will find the answers on the next slide. You can pause now. Okay, so now you can see the answer. Well, I hope you did them correctly. Now again, John is a good man. We have just used G, so I'm just using G here, right? And here, John is a good and kind man. Again, we have the operator and as I told you before, John is a good man, John is a kind man. So we say John is a good man, and a kind man becomes good and kind, okay? Now here we have either or, so we have or. So let's just do it like this. Say John is a teacher or John is a student. Okay, so teacher or student, and then I've used the wedge. Okay. Here, John doesn't like this lesson. Excuse me. John doesn't like this lesson, so we have L, lesson, right? But because it's negative, so I've used the tilde, so not L, okay? Next, if John studies hard, then he'll pass the course. Now you can see, instead of writing if, then, I've used an arrow, and study and pass. So how do I read this? I just say if S, then P. So that is, if John studies hard, then he'll pass the course. And finally, we have this, John will pass the course if and only if he studies hard. So we can just write it like this, P, pass, right? And S is study. So we say P, if and only if S. This is a different way of writing the same sentence, but it's a bit different, and we'll see how it is different, okay? But for now, what is this? This is a conditional operator. What is this? A conditional operator. What is this? This is a conjunction operator, right? So now we have if and only if. Now, if you've noticed, here we have changed the S and Q's, right? So this could suggest if we have if, we write it like this. If we have only if, we write it the other way around. And then when I'm talking about two concepts of sufficiency and sufficient condition and necessary condition, you will see why we do it. Negation as one of the operators. That's the first operator we're going to talk about. And here we have a truth table, as you can see. So let's go back to our previous example. I'm from Iran. And this time, because in your book they have used P, let's just say P represents I'm from Iran. So it can be true that I'm from Iran, or it can be false that I'm from Iran. As you can see here, we have two truth values, true or false. Naturally, if there is one proposition, we have only two levels or two rows, we say. What about the opposite one? I mean, if we have the negative form, not P, that is, instead of saying I'm from Iran, if I say I'm not from Iran. So if this is true, I mean, P is true, then definitely I'm not from Iran is false, right? I mean, we have a complementary, in a sense, meaning, right? If this one is true, this one should be false. But what if this is what I'm from Iran is false? Then the opposite, I'm not from Iran, is true, right? Okay, so this is represented by, I said, I mean, negation is represented by tilde, right? So we have not P or tilde P. Now I'll give you some examples, and I want you to translate these statements. As you can see, we have not, or it's not the case that, to represent negation. Okay, so not, or it's not the case that. So let's move ahead and see what we have on the next slide. Okay, now look at these examples and translate these ordinary claims into propositional forms. Remember, it does not matter what letters you use. For instance, for the first one, write a J or an I, whatever, okay? Now pause the video and write your answers. By the way, before you pause, a clue. All these statements are negative. So you can first ignore the negative and write the letters and the operations, and then put the tilde before the whole symbol, okay? Go ahead. Good. Here, you can now see the answers. Okay. Now, something important is to know what the main operator is, as I mentioned, right? So what we will see in maybe the slides that will come will be what we mean by that, maybe more specifically. But here we have only one claim in number one. Jack is not from Iran, J, and I've used J here, for example. And then I've used this tilde right before this tilde before J, so not J, right? Now look at this second one. Look at this second one. The second one is it's not a case that, and let's forget about it's not the case that for now. Say it's, if Jack is not from Iran, he will pass the course. Now say, so we have two operations here, but this operation here is if then, right? It's a conditional, if then. And then I've written here J for Jack, and will pass the course. P would be if J, then P, right? But then let's look at this, it's not the case. Now, is this, it's not the case, referring to if Jack is from Iran? Or is it referring to he will pass the course? Or is it referring to, let me just write here the parentheses, is it referring to the whole thing? Obviously, it's referring to the whole thing. That's why I have put it here outside of the parentheses. Is that right? Now, same applies to this sentence, neither Jack or Mary is from Iran. Is that right? So here we have J or M, but not applies to both of them. Okay, applies to both of them. One more thing. Here we have only one claim. Is that right? I mean, if I say Jack is not from Iran. So when I have one claim only in the first sentence, then what happens here is that I will have two truth values, right? So there will be two rows, row 1 and row 2. Is that right? Yeah. So P only has 2 rows. It might be easy for you to remember that the number of rows is a function of the number of claims. What does this mean? It means if we have 2 propositions, then we will have 4 rows. If we have 3 propositions, then we'll have 8 rows. And to understand this better, that would be 2 to the power of the propositions. So I'll just write PS to say that. So if you have one proposition only, it becomes 2 times 2 to the power of 1, which is 2. If it is 2 to the power of 2, that would be 4, right? So it means we'll have 4 rows. And so on and so forth. Let me just give you another example. If we have 3 propositions, then that will be 2 to the power of 3, which will be 2 times 2 times 2, which will make it 8, and so on and so forth. Is that right? So 2, in a sense, n will refer to the number of propositions we'll have, will give us the number of rows we will have in our truth value table. Let's look at the next one, which is conjunction. So this is our next operator. A conjunction is something like P and Q. So we have 2 propositions. One is P, one is Q. Is that right? So remember, we used ampersand to refer to this, right? So if I say I'm from Iran and I'm a teacher, let's say I'm from Iran is my P, and then I'm a teacher is my Q, okay? And then here we have the operator and, so this is and, right? The operator and. Now, let's write it like this, P and Q, and I'll just see that here we have P and Q. But remember, this ampersand does not only refer to and, it can also include other concepts such as but and while. But we call it a conjunction. So let's look at this table. Here we have 2 propositions. One is P and the other one is Q. Now, so how many rows should we have? When we have 2 propositions, we should have 1, 2, 3, and 4 rows. Is that right? So usually for the first proposition, we just write all the true possibilities and all the F possibilities after them. Okay, so this means we can have a truth value for P and also truth value for Q. The second one would say P might be true, but F is false. And then the truth value of P is false, but the truth value of Q is true, and both of them are false. But what happens if my first proposition is true and the what the second proposition is also true, then this operator and would be true. Okay? And actually, it's the only time that and can be true when both P and T are, when both P and Q are true. Other than that, that will be always false. So, I think this is clear, right? I'll show you one of the things that Parker and Moore have used in their book, and that is the light bulbs. You will see that, and I think that it can help you grasp the idea better. Okay, so anyways, what this means is when we want to have the conjunction operator and, but, while, then when I want to check its truth value, I'll have to make sure that the two propositions are true, and then okay. The next one is a disjunction. For example, either Mary is at work or John is at home. Mary at work, let's say, is P again, and John is at home is our Q, okay? So here the operator is or, right? Okay. Remember, in disjunction, each operator is called, each proposition is called a disjunct. So this is one disjunct, and this is another disjunct, okay? Now, again, we have P's and Q's. Maybe we should remind our P's and Q's. That's why they've chosen this. Anyways, P and Q, these are the symbols which they have used here. And it really doesn't matter what the letters are, right? I've told you several times because in our previous video, we just used S and P for subject and predicate terms. So we think that this might be the case, but it's not really the case. So what is the operator here? The operator is disjunction. And what is the symbol for disjunction? A wedge. So what logical function does a wedge have? Wedge here, as you can see here. What logical function does a wedge have? Disjunction, okay? So now let's look at the table and see how many claims we have first. Again, we have two propositions, so we have 1, 2, 3, 4 rows. Is that right? Again, so how many propositions do we have? 2. How many rows can we have for them? 4. Now, you can pause the video now and see what the truth value of the operator will be depending on the truth value of each proposition. Please pause and then come back. Okay, I hope you figured out. As you can see, this is the opposite of conjunction. It means if the truth value of P and T are both true, then it will be true. The operator will be true. If P is true, but Q is false, that doesn't matter. That will be true. For this third one, again, doesn't matter. It's only false. I mean, the operator disjunction is only false when both of these are false. Okay? Now, look at the sentence again here. Either Mary is at work or John is at home. Maybe something worth mentioning here is that some of you might think that one of them is maybe true, one of them is false. Remember that we have two types of disjunction. One is exclusive disjunction and the other one is inclusive injunction. Inclusive injunction is when both can be true, but exclusive is only one of them can be true. So if it is exclusive, only one is possible. So let me just write exclusive maybe here, exclusive, right? So exclusive and inclusive, right? I don't need to write inclusive, I think, but I'll just write in. All right. So as I said, if it is exclusive, only one of them is possible, but if it is inclusive, both of them are possible. Or maybe one, or either this or that. So for example, if I say either eat or don't eat, it's exclusive. It means one is true and the other one is false. If you eat, the other one is false. But if you don't eat, then the other way around, right? So in inclusive, it means that if one is true, the other one is not necessarily false. One is true, the other one can be true, or both of them can be true. Okay. So it can be the case for both, right? So when I say either Mary is at work or John is at home, if it is inclusive, it means that maybe Mary is at work, and that is true. Maybe John is at home, and that is true. And maybe both. Mary is at work, and John is at home. That is true, because they are they're not interdependent. Here is maybe what we have in Parker and Moore, and it can help us. This first diagram here is a very helpful one for us to remember the truth value we had. Let me just write the truth value of P and Q here, so it can help. Maybe I wish I had put this on the one so I wouldn't have to spend time writing this one. Remember, we just wrote all the truths first for the first proposition, and then the second one, and here we would alternate between false and true. Okay. Okay. So now let's look at this one, and then say P. Oh God, how can I write ampersand? Okay, now this is ampersand, okay, and this is Q. So what is the truth value of and for us? All right, now, we said that if both of them are true, this can be true. In all other cases, it would be false, false, and false, okay? All right, sorry for the terrible handwriting. Now, now look at the idea of the light bulb. Now, if P is like this, not connected, and this one is not connected. Not connected means false, okay? If this is false and this is false, will the light go on? No. Well, what if I connect them? It means it's true. And this one is also true. Then it is true. It means the light bulb will be on. Now, what if one is true, the other one is false? So let me just rub it off. So this one is connected, but this one is not connected. So we can't get the current to the light bulb, so it won't go on. This is what happens in serial circuits, right? Okay, let's look at the second picture. And the second picture, as I'll try and use here, would be the disjunct function. Again, I'll have P, or maybe I could use this, that would be quicker, okay? And write it here, Q again, all right? And write what? First one was true, this one, why did I wrap this off? Okay, okay. Now, so P wedge Q. Okay. Now, we only said that this can be, if they're both true, it's true. If one is true, then it is true. If one is true, then it is true. If both are false, then it is false. And now, let's look at our diagram. Can electricity get into the bulb? It can't. Why? Because they're both disconnected, both false. So we can't have a light bulb, all right? Now, what if I say one of them is true, the other one is false? Now, electricity can get into the light bulb. What if this one is what? True, but this one is false. Again, the electricity will get this time through here to the light bulb. Now, what if I have both of them as true? Then it can get either way. And what happens is that both of them are true. Now, why do we need these? You will see later why we need them. But this is going to be very important for you to check the validity of the operators, as you can see. Conditionals. This is said to be maybe the most difficult operator. Well, when you do some exercise, you'll see that it's not as difficult. Well, let's look at the sentence. If you heat water to 200 degrees, then it boils. You can see that the operator here is the arrow, right? So what is the operator? Here you have the operator arrow. All right. Well, I said that in some, you might just see a horseshoe, right? Okay. Now, when you have a conditional, it means that there is an operator, right? But when can a conditional or an arrow be true? Now, again, you can pause the video now and check this table here, okay? Check this table here. Pause. All right, I hope you could just get a hang around it. Well, when a conditional, remember we said P in the conditional is the antecedent and Q is the consequent. A conditional can have a false value if and only if the antecedent is true, but the consequent is false. In all other cases, the condition or what the operator here we have implication is true. Can you see that? Right? All right, so it might be a bit confusing for you because you're just trying to figure out why this is the case. Now, we are not going to spend a lot of time on this, but you will see in due time, okay? So let me just say here P represents, so I'm just going to use P here for you. P, and it boils for Q, because I'm using P and Q because here I don't want to confuse you with some more letters. So here we have P, okay? And then here we have Q, boils. So now P represents heating and Q symbolizes boiling. Now, there are a few things I should mention here because as we move on, we might have to use them. One, as I mentioned earlier, and also right here on this slide, the first event, P, is called the antecedent, okay, antecedent. And the second one is called the consequent, right? Okay. Now, sometimes you might hear two concepts, and that is what we need to learn. The concepts are necessary and sufficient conditions, okay? Now, a condition is sufficient if and only if the occurrence of a phenomenon depends on it. Now, look at this example that I give you. If I say, if you win the race, we will celebrate. Your winning the race is a sufficient condition for us having a celebration, right? So remember, sufficient conditions are expressed as the antecedents of conditional claims. This is very important. So let me just repeat it once again. Sufficient occurs as the what? as the antecedents. It means if S, then. Why did I say S? Let me just write if P, because here we have P. If P, then Q. What was this? This is P, and P is the antecedent, and the antecedent is the sufficient, remember, sufficient condition. Okay? Let me finish this. Now, I don't know. I guess I'm suffering from some problems, and I have to write the whole thing. All right. So if P, then Q, which is represented by P arrow Q, how do we read this? We just read it like if P, then Q, if P, then Q. So when I write it like this, then I understand that this is the antecedent. Definitely, this should be the sufficient condition. Okay. Now, but what about necessary conditions? Necessary conditions are stated as the consequent. Okay, so this would be then the consequent. Okay, the consequent condition. So if I say the presence of oxygen is a necessary condition for combustion, so this tells us that we can't have combustion without oxygen. So if we have combustion, then we must have oxygen, right? So we say combustion, oxygen. So oxygen is a necessary thing for combustion. Notice that, excuse me, notice that the necessary condition becomes the consequent of a condition, okay? Now, maybe something else which is worth mentioning is if and only if can also signal sufficient and necessary conditions. Remember that if is placed before the antecedent, but only if comes before the consequent. So if you have only if, it means what comes after is a consequent. Did I say it right? I don't know what I said. Okay, so let's look at some examples to understand these concepts better. All right, let's see whether you've answered them correctly or not. Well, before we answer them and you check your answers, let me tell you about the idea of sufficiency. When you work somewhere, it's you get paid. Getting paid is necessary for working. If you don't get paid, obviously you won't work there. Is that right? So it might be necessary, but is it sufficient? Maybe not. That's why you have a second job, maybe. So it is necessary, but it's not sufficient. Remember that if by itself introduces a sufficient condition. So if we have, if, for example, P then Q, as we have here in the first one, if Q then P, then it means that Q is the sufficient condition. But the phrase only if introduces a necessary condition. All right, so with that in mind, let's just read them. Here, if Quincy learns to symbolize, Paula will be amazed. Now, as you can see here, this is our sufficient condition for Paula to be amazed, right? So I just write it like Q arrow P. Why? Because Q is what? Is sufficient. And when it's sufficient, it appears, in our notation, it appears before the arrow. Okay. Now look at the second one. The second one is the same thing. The only thing is that if, because it's an adverbial clause, is moved to the second position after the main clause. So it's the same idea still, that becomes if Q, then P. And as you can see here, if Q, then P, right? Because what comes after if by itself, as I said, introduces a sufficient condition. And sufficient comes before. So remember, sufficient, then N, necessary. So that would be sufficient then necessary. So, okay. What about this one? This one, as you can see, we are having only if, right? Only if. Now, Paula will teach him only if Quincy pays her a big fee. So remember, only if introduces a necessary condition. And where does a necessary condition appear? If we just want to write the conditional, that appears in the second position. So what I need to do is put this Q here in this position, because this operator works like this. So what I do is write P, right? And then my operator, and then Q, as you can see here in number 3. Okay, I think with the same process, you can go ahead with number 4 and 5. This table and check the truth value of an argument. Well, of course, you don't have the argument here. But let's imagine that we had an argument and we translated into this formula, okay? P, arrow, parentheses, Q and R, close parentheses. So let me just rub it off, because we might just need to do some other things with it. So imagine the translation is this, and let's just say we have P and arrow and Q and ampersand. Well, very difficult thing to draw here, and R. Okay. Now here, how many propositions do you see? 3. P, Q, and R. And how many operators do we have? 2. One is and, one is the arrow, which is for the condition or implication. Now, which one is the top level operator? Which one is the main operator? We don't know here, but let's say that we know that the top operator is here. So in this case, and remember, before I say what about this case, remember that always there's got to be one top level operator. So when we read a sentence, we have to decide what the main operator is. So here, because I know that the condition is the main operator, I need to set this off using the parentheses. So parentheses actually help us, as I mentioned earlier, to decide what this operator is applied to. This applies to Q and R, right? But this operator applies to P and the whole, what? Q and R. So if this is the case, now let's move back here and see how many propositions do we have. How many propositions do we have? 3, P, Q, and R. Now remember, we said that if we have 2 propositions, we raise it to 2, and then we get 4 rows, right? But if we had 3 propositions, that we do it here, so that becomes 2 to the power of 3, that makes it 8 rows. We need to have 8 rows. So let's check 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so that's right. Now, let's say that when we have 8, so half of them should be true and half of them should be false. And this is how we write it. And then for Q, you can see we write 2 T's and 2 F's and so on. And we alternate between T and F for the third proposition. Now, because Q and R is what the propositions for our operator and, let's first focus on Q and R. Remember, again, I'll have to write it here. For conjunction, what was the operator we had, for example, P and Q there, but let's say Q and R here. Q and R. We said that for this, both of them should be true for the operator and, okay, this is an ampersand apparently, okay, so I'm sorry, and to be true, right? All the other options we had, which was true F, would give us an F. F and true and F would give us, again, F and F. So now here, let's look at Q and R and to see where they are both true, so we can have a true operator here. So T and T, so that would be true. Here, T and F, that would be F. F and T, F. F and F, F. T and T, true. Okay. And all the rest are false again, right? Now, we have decided that Q and R can only be true if both of them are true. Is that right? That's right. What about the condition, the operator for condition? So pause the video now and think of the operators for condition as we mentioned earlier. Okay, I hope you remember. Let me just clear off these things now and say, okay, we said that for conditions, our condition would be false only if, or if and only if, the antecedent was true, but the consequent is false. You see, here it is true, here it is false, so definitely this is false. If both of them are true, it is true. If this one is true, but this one is false, then it will be false. If this one is true, this one is false, then it is false. If the antecedent is false, it doesn't matter what the consequent is, it will always be true. Is that right? Okay, so I think we're almost there for this week. All you need to do is practice and practice and practice to get a hang of all these things. I'm sure some of you are familiar with the ideas because you have studied them before, maybe in your other courses. Okay, so I'll send you the assignments on your Classroom, Google Classroom. Thank you very much for watching. Goodbye.